We all remember third grade science, right? You take a bean, you put it in a wet paper towel, you stick it in a plastic baggie on the window, and a few days later, boom, life. We've known since we were 8 years old that plants need water, sunlight, and soil to grow. It's one of those fundamental truths we just accept, like the sky is blue or taxes are inevitable. But here's the thing. Look, most of us have been looking at this completely backward for our entire adult lives. My name is Mark. I'm just a regular guy like you, but I spend way too much time thinking about how a plant actually grows. I mean, think about it. If you're the kind of person who stares at a massive 100-foot oak tree and wonders, wait, where did all that physical stuff actually come from? Then you're in the right place. Before we dive into the wealth of the natural world, make sure to hit that subscribe button and give this video a thumbs up if you're ready to look at your garden a little differently today. Let's start with a challenge to your common sense. If I asked you where the physical weight of a tree comes from, you'd probably say the soil, right? It's in the ground. It sucks up nutrients. It gets bigger. Well, here's what most people don't realize. Plants are not made of dirt. If a tree actually grew by eating soil, there would be a massive hole in the ground around every single tree on the planet. But there isn't. Back in the 1600s, a scientist named Jan Baptist van Helmont actually tested this. He planted a willow tree in a pot, weighed the soil, waited 5 years, and waited again. The tree gained 160 pounds. The soil, it lost about 2 ounces. 2 ounces. So if it's not the dirt, what is it? Now you might be thinking, Mark, it's obviously the water. And sure, water is the transport system. But the actual wood, the structure, the carbon, the tree is made of thin air. Literally. This is where it gets really interesting. A plant is a carbon capture machine. It breathes in carbon dioxide, keeps the carbon to build its body, and spits out the oxygen as a byproduct. When you look at a massive wooden table, you are looking at organized, solidified air. Let's break down the business model of a seed. Think of a seed like a tiny high-tech startup with a very limited amount of venture capital. Inside that shell, you have the embryo. That's your founder, and the endosperm, which is the initial funding. That seed can't make its own food yet because it doesn't have solar panels, aka leaves, to catch the sun. It has to survive entirely on its savings until it can break the surface. This is why planting depth matters so much. If you bury a tiny seed too deep, it runs out of cash before it hits the light. It goes bankrupt and dies underground. But once it hits the light, that's when the photochemical phase kicks in. Look, we talk a lot about efficiency on this channel, but nothing, and I mean nothing, is as efficient as a chloroplast. Inside the leaves are these tiny green factories. They take photons, light particles, and use that energy to rip water molecules apart. It's basically cold fusion in your backyard. They take carbon dioxide, water, and light, and they turn it into glucose. That's sugar. That's energy. The plant takes the energy from the sun and stores it in the chemical bonds of that sugar. Now, why should you care? Because every single calorie you have ever eaten, whether it's a steak or a salad, is just repackaged sunlight. We are literally powered by the sun, just with a few extra steps in the middle. Now, here's an objection I hear a lot. Okay, Mark, I get the air thing, but how does water get from the roots to the top of a 300-foot redwood tree? They don't have hearts to pump blood. This is the part that frustrates me, because we simplify it too much. They don't suck water up like a straw. It's cooler than that. It's called transpiration. Imagine a long chain of people holding hands, stretching from the basement to the roof. On the roof, the person at the end jumps off. Because everyone is holding hands, they all get pulled up one step. Water molecules are sticky. As water evaporates out of the leaves through tiny pores called stomata, it pulls the next water molecule up behind it. The sun literally pulls the water up the tree. The tree doesn't spend a single ounce of energy moving water. It's a passive solar-powered hydraulic system. This is where it gets really crazy. We think of plants as individuals, but they are actually part of a massive underground trade network. Most plants have a partnership with fungi called mycorrhizae. The plant says, hey, I'm great at making sugar from the sun, but I'm not great at finding minerals in the dirt. The fungi says, I've got miles of tiny filaments to find minerals, but I can't make sugar. So they trade. The plant sends up to 30% of its total energy production underground to pay the fungi for minerals. It's a literal marketplace happening under your feet. So, why did I want to talk about this today? Because when you understand how a plant grows, you stop seeing the world as a collection of stuff and start seeing it as a series of systems. A plant takes the most chaotic things in the universe, raw sunlight, gas from the air, and dirt, and turns them into order. It turns them into life. It's a lesson in patience, efficiency, and resource management. Next time you walk past a tree, don't just see a piece of landscaping. See a massive solar-powered, carbon-capturing, fungal-trading masterpiece that built itself out of thin air. If you learned something new today, do me a favor. Share this video with someone who thinks they have a brown thumb. Maybe they just need to understand the business of biology a little better. As always, I'm Mark. Thanks for watching. Go plant something and I'll see you in the next one.